Hi Pre-Calc. We are taking some notes on 2.4 real zeros of polynomial functions. We are going to consider the graph of 6x cubed minus 19x squared plus 16x minus 4, which is the function that you see on the screen. And I want to factor this function. So factor means we know this, get all the things that multiply together to get this function. If I look at it, it's not a quadratic, so it's not going to use the quadratic formula, and it doesn't look pretty easily factorable. So what do I do? Well, I can use the graph a little bit. If we notice, this x scale goes from -1, 2, 3, 4, and 5. And so I can see some of the x-intercepts. It says, what are the x-intercepts? Well, I can see this one very clearly. The x-intercept at 2, 0. I feel good about that one. And then I see that there's two other ones, but these are a little more unclear. It's not super obvious to me what they are. I'm going to make a guess that this first one is 1/2, 0, but the other one I don't actually know. It's something, 0. It's not obvious to me what that point is. If I know the x-intercepts, then I really know a lot about this function. From these x-intercepts, I can take the zeros, right? X equals 2, x equals 1/2, and x equals, well, we don't know. And then from these zeros, I can change these into factors. X minus 2, this one would be 2x minus 1. Think about it. If I add 1 to the other side and divide by 2, I get 1/2. And then we have x minus something, right? We still don't know this third factor. But technically, I have 2 out of the 3 factors, or the things that multiply together to get to our function. 6x cubed minus 19x squared. Ooh, oh my goodness, sorry. Minus 19x squared, where was I? Plus 16x minus 4. So if my goal is to factor completely, I need to solve for this factor. How the heck am I going to do that? Well, let's start at the very least by foiling out these first two factors. So we have x times 2x, 2x squared, first outside, minus x, inside, minus 4x, last, plus 2. I still don't know this factor, x minus question mark. And this is equal to 6x cubed minus 19x squared plus 16x minus 4. Okay, well, that was helpful, but not quite enough, right? How am I going to solve for this factor? Well, technically, I would divide both sides by, this is really 2x squared minus 5x plus 2, right? I just added these guys here. So if I divide both sides by 2x squared minus 5x plus 2, I will get my answer. But we haven't done anything like that. So we're actually going to do some long division, which I realize might at first seem like, oh my gosh, we're doing long division? What? I'm not in, 6th grade when we did long division, but I promise you it's not that bad, and I think it's kind of fun sometimes. So let's set up our long division. I have 6x cubed minus 19x squared plus 16x minus 4, and I'm dividing that by 2x squared minus 5x plus 2. Maybe you remember long division, maybe you don't, but I think it's going to come back to you. The first step is to ask ourselves, how do I multiply 2x squared by something to get 3x cubed? Well, I know 2 times 3 is 6, so I'm going to need a 3, and x squared times 1x is going to get me to the x cubed. So I'm going to multiply it by a 3x. Then I multiply every piece by that. So 3x times 2x squared is my 6x cubed. 3x times a negative 5x is a negative 15x squared. And 3x times 2 is plus 6x. I am going to subtract this entire thing. 6x cubed minus 6x cubed is 0. Good, we want to cancel things out. Negative 19x squared minus a negative 15. Well, technically, minus a negative, we are adding. So I have negative 19 plus 15, negative 4x squared, and then I have 16 minus 6. So plus 10x, and then we drag down this 4. And then we do it all again. So I ask myself the same question. How do I get from 2x squared to negative 4x squared? I'm going to multiply that by a negative 2. Negative 2 times 2x squared is a negative 4x squared. Negative 2 times a negative 5x is a positive 10x. And negative 2 times a positive 2 is a negative 4. And notice this entire thing, when we subtract it, each of those terms cancels out, right? Negative 4x plus 4x squared, those are going to cancel. 10x minus 10x, those cancel. Negative 4 plus 4, these cancel, which is exactly what we want. And lo and behold, we have our last factor, 3x minus 2. Now, if we think about this, if I solve for the 0, I would get 3x minus 2 is equal to 0, 3x is equal to 2, x is equal to 2/3, which, if we look back at our picture, that makes sense. This other guy, oh my goodness, what just happened? This other guy right here, that looks like about 2/3. I feel good about that. My final factorization then is the x minus 2 times 2x minus 1 times 3x minus 2. I have fully factored my polynomial from above. That is what this section is all about. Let's do another long division problem. So we are going to divide 6x to the 4th minus x cubed minus x squared plus 9x minus 3 by x squared plus x minus 1. So we're going to set it up like we did. 6x to the 4th minus x cubed minus x squared plus 9x minus 3, and we are dividing that by x squared plus x minus 1. All right. First move. How do I get from x squared to 6x to the 4th? I need a 6 and I need an x squared. 6x squared. So we multiply. 6x squared times x squared is 6x to the 4th. 6x squared times x is 6x cubed, and 6x squared times a negative 1 is a negative 6x squared. I am subtracting this entire thing. That's the biggest mistake people make, so be very careful. 6x to the 4th minus 6x to the 4th is 0. Negative x cubed minus 6x cubed is a negative 7x cubed. And then we have negative x squared minus a negative 6x squared. So I have a positive 5x squared. Then we pull down the 9x and the 3, and we start all over again. Ask yourself, what do I multiply x squared by to get negative 7x cubed? And that would be a negative 7x. So we multiply. Negative 7x times an x squared is a negative 7x cubed. Negative 7x times x is a negative 7x squared. Negative 7 times a negative 1 is a positive 7x, and we subtract. So this first term cancels out because we made it do that. Then we have 5 minus a negative 7, or 5 plus 7. We would get 12x squared. Then I have 9 minus 7. I get a 2x, and I drag down that 3. And we got one more loop to do. Sorry, I'm trying to extend the page. There we go. So what do I multiply x squared by to get 12x squared? Well, that would be a 12. So 12 times x squared is a 12x squared. 12 times x is a plus 12x. And 12 times negative 1 is a negative 12. We are subtracting this entire thing. 12x squared minus 12x squared is 0. 2 minus 12 is a negative 10x. And negative 3 minus a negative 12, really, negative 3 plus 12 is plus 9. But notice now, we can't do any more multiplication to get from x squared to 10x. So this, what we have left over, is known as a remainder. Now, to give you a really simple example of this, of how we're going to write our remainder, I want to consider, let's do 14 divided by 3. Okay, this is a really simple, like we wouldn't ever do long division here. 3, how does it go into 14? Well, I know if I do 4 times 3 is 12, right? 14 minus 12 is 2, and this is our remainder. Think about this. 14 thirds is really, right, 4 and 2 thirds. Well, look, here's our 2, here's our 3. 4 and 2 thirds. So we're going to take our remainder, the negative 10x plus 9, and divide it by this piece over here. So x squared plus x minus 1, and we are adding that to our polynomial. And here is our little solution. Kind of beautiful. I don't know. I think it's beautiful. Another method for division is called synthetic division, and this is going to probably be the type of division you like the most because it's actually a lot easier than long division. The only catch is I can only use synthetic division if I'm dividing by a first degree binomial. So only can use when dividing by a first degree binomial, meaning something like x minus a to the first power. Anything else I cannot do. So if I had, for example, x minus a squared, well, sorry, x minus a that thing squared, I really wouldn't be able to do this division. But here I can. 5x cubed plus 8x squared minus x plus 6. We're dividing that by x plus 2. For synthetic division, we really only use the coefficients. So I'm going to take these coefficients, 5, 8, negative 1, and 6. Those are my coefficients. And I am going to take the 0 that comes from this factor. So the factor is x plus 2. That means my 0 is negative 2. I'm going to put negative 2 out here. In synthetic division, it's kind of, I don't really know a good way to write what we're doing, so I'm just going to show you. You start by taking this first number, pulling it down, and it's just, it hangs out down there. Then we take 5 times negative 2, 5 times negative 2, which is negative 10, and we add these two numbers. 8 plus negative 10, we get a negative 2. Then we repeat that process. Negative 2 times negative 2 is a positive 4, and we add down. Negative 1 plus 4 is a positive 3. 3 times negative 2 is a negative 6. 6 minus 6 is 0. This is what we want. This says that I have no remainder, which is what we want here. No remainder. Well, what's my answer then? We take these guys and we change them into our polynomial. Specifically, as we go from right to left, they have increasing x value. So this first value will have no x, this one will have 1x, and this first one is x squared. We still have our factor from above, x plus 2. And this technically, when we multiply these things together, right, is going to be the 5x cubed plus 8x squared minus x plus 6. And we did our division. That's really it. Why is this something we want to do in this class? Well, let's look at a couple theorems. The first is the remainder theorem. And it says if a polynomial is divided by a factor x minus k, then the remainder r is equal to f of k. So that sounds kind of complicated. Let me unpack it. I pulled in the last example so that we could talk about what we're saying. So if a polynomial, we took the polynomial 5x cubed plus 8x squared minus x plus 6. If I take this polynomial and I divide it by some factor, some binomial, then the remainder, whatever that remainder is equal to f of k. So we took x minus, oops, just kidding, x plus 2. So if I was asked to find f of 2 here, right, so f of k, k is 2 in this case. Sorry, I'm pausing because I made a mistake. X minus k, which means in this case, k is negative 2. Okay, I'm so sorry. Let me back up and make sure you're with me. Sorry about that. I can't really go back in the video, so it is what it is. Okay, here's our function. 5x cubed plus 8x squared minus x plus 6. When we divided x plus 2, which we saw was a factor. How do we know it's a factor? Well, we know it's a factor because it didn't have a remainder. It divided out perfectly. X equals negative 2 was the 0, which meant also it is a x-intercept, right? Negative 2 comma 0. Or another way to write that is f of negative 2 is equal to 0. We know all of these things. These are all of our facts from our last lessons, right? A factor is a 0, is an x-intercept, and we can write it like this, like a solution. That's what this theorem is saying. If I take a polynomial and I divide it by x minus k, then f of k is equal to the remainder of 0. So let's try and see what we can do here. Use the remainder theorem to find f of 1. Now, I will point out, we could definitely just plug in 1. F of 1 is equal to 1 cubed minus 2 times 1 squared minus 4 times 1 plus 1. So we get 1 minus 2 minus 4 plus 1. Hopefully, 1 minus 2 is a negative 1, minus 4 is a negative 5, plus 1. Hopefully, when I do this, I get the answer of negative 4, because that's what I know it should be. We're going to do it another way, though, just to show that this remainder theorem works. Specifically, we're going to use synthetic division. So I get my coefficients, 1, negative 2, negative 4, and 1. And I want to find f of 1. So I'm going to put a 1 outside here. Drag down the 1. 1 times 1 is 1. Negative 2 plus 1 is a negative 1. Negative 1 times 1 is a negative 1. Negative 4 plus a negative 1 is a negative 5. Gives me a negative 5. When I add these, 1 minus 5 is a negative 4. Notice, this is our remainder. And what we are saying here is f of 1 is equal to -4. It's another way to get this same answer. Now you might be thinking, why would I do this over that? And honestly, I don't really know. But there might be occurrences when it's probably faster to use synthetic division than it is to plug in the value. Now, that's not quite all we can do here. I got another theorem for you, and it's the factor theorem, which says a polynomial is a factor if and only if f of k is equal to 0, which we actually already saw and we feel pretty good about. So let's show that x plus 3 is a factor of x cubed minus 19x minus 30 and find the remaining factors. So I'm going to start by getting my synthetic division set up. I want to put the coefficients, and this is a really important example because we need to put some placeholders. So we have x cubed plus 0x squared minus 19x minus 30. That placeholder is extremely important. So 1, 0, negative 19, negative 30, and I want to show that x equals 3 is a factor. If x equals 3, x plus 3 is a factor, that means x equals -3 is the 0. So I'm going to put a -3 out here. Bring down the 1. 1 times -3 is -3. 0 plus -3 is -3. -3 times -3 is a positive 9. Negative 19 plus 9, negative 10. Negative 10 times a -3 is a positive 30, which is great. We're getting a remainder of 0, which is proof that this x plus 3 is a factor. I have factored it out completely. What I'm left with here is x squared minus 3x minus 10 and x plus 3. And then it said factor completely. Well, now this is easy. X squared minus 3x minus 10, I can factor that. Oops, that was supposed to erase. I can factor that, no problem. Consider for a second what this would factor into. And hopefully, you're getting x minus 5 and x plus 2. Beautiful. Factored version. The last and final thing in this section is possible rational zeros. So in the chance that you can't find a function can't find a function, can't find a graph, we don't really want to like guess and check. That probably seems way too hard, right? I don't want to just guess random points. And so the possible rational zeros can at least kind of narrow down our search. Possible rational zeros are going to be found by taking the factors of the constant term divided by the factors of the leading coefficient. So let's find the possible rational zeros of x cubed minus 7x minus 6. The possible rational zeros. So the factors of the constant term. The constant, in this case, is -6. So the factors of 6 are plus or minus 6, plus or minus 1, plus or minus 2, plus or minus 3, all over the factors of the leading coefficient. Well, our leading coefficient is just 1. So the factors of that are positive or -1. We would technically do all these divisions. So 6 divided by 1 is either positive or -6, positive or -1, positive or -2, and positive or -3. Now, these are not the answers necessarily. These are possible zeros. But it's a lot better. So this is 2, 4, 6, 8. 8 possibilities is a lot better than an infinite amount. So let's say we wanted to actually do some division here. Well, we could test one of them out and see if it gives us a factor. So I'm going to put in my coefficients 1, 0, a placeholder for the x squared, -7, and -6. I am going to guess, just for fun, I'm going to guess 1. So I pull down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -7 plus 1 is a -6. -6 times -1 is -6. And this is -12. What am I seeing? A remainder, which isn't 0. So x equals 1 is not a 0. Ugh, well, that's okay. We can try another. Let's try another. Sometimes you'll get lucky on the first try, sometimes you won't. Let's try -1. So we have 1, 0, -7, -6. Start by pulling down the 1. 1 times -1 is -1. 0 plus -1 is a -1. -1 times -1 is a +1. We would get -6, a +6, and hey, that is a factor. So x equals -1 is a 0, or x plus 1 is a factor. Now I have an easier thing here, right? This is x squared minus x minus 6. That I can factor no problem. X minus 3 and x plus 2. And our original one we just found, x plus 1, and we're golden. All right, have a wonderful day.